Lesson 13.3, Task 3. Determine a term in a geometric sequence. A geometric sequence has a fifth term that is 125 and a common ratio of 5. Write a rule for the sequence. What is the 10th term? All right, so there's two things that we need to do here. We're going to write a rule for the sequence and then determine what the 10th term is. So to write a rule, we need the first term and we need the common ratio. We're given the common ratio, but we're not given the first term, we're given the fifth term. Okay, so we're going to have to use that information to figure out what is the first term. All right, so it says, can the 10th term be found directly using the fifth term and the common ratio? Explain. So the answer to that is yes, because if I take 125 and I know that's your fifth term, I can multiply that by 5 to get your sixth term, take the answer, multiply that by 5 to get the seventh term, so on and so on. All right, so it says yes, you can multiply the fifth term by 5 times the common ratio to find the 10th term. Yes, you can find the sixth term by multiplying the fifth term by the common ratio. Then find the seventh term by multiplying the sixth term by the common ratio. Continue that until you get to term 10. So that is the correct answer here. And then it says, no, you cannot. You can get to the 10th term given the information above. All right, in order to write the rule for a geometric sequence, you need to determine the value of the first term. So we know the general rule, a sub n equals your first term times your common ratio raised to the n minus 1. All right, so we can take the information that we are given and plug it in. So we know we're given our fifth term. So what they're doing is plugging in n for 5, and our fifth term equals 125. So all you have to do is solve for the first term from there. So we're given 125, and we are looking for our first term. That's the only variable now. And we have 5 to the 5 minus 1 power. Okay, so remember it's your first term times your common ratio raised to the n minus 1. So in this case, n, our fifth term, is 125. That was our given information. So we just plug that in and now we can solve. So 125 equals our first term. Remember, again, it's always order of operations. So you have to do 5 and then raised to the 5 minus 1 is the fourth power. And 125 equals our first term times 5 to the fourth power is 625. And then I've got two things multiplied together, so I need to divide. So our first term is going to be 125 divided by 625. And that turns out to be 1 over 5, so 1/5. So our first term is 1/5. We were already given our common ratio of 5. So R equals 5. And a sub 1 equals 1/5. All right, how is the rule written in subscript notation and in function notation? All right, so subscript notation, remember subscript just sits below the variables, kind of like an exponent sits above the number, subscript sits below. So a sub n equals our first term times our common ratio. So our first term is 1/5 and our common ratio is 5 raised to the n minus 1 power. And then the rule written in function notation would be the same thing, except it's going to be a parentheses n equals 1/5 times 5 to the n minus 1 power. All right, so it says use either form of the rule to determine the 10th term. All right, so we just plug 10 in for n, and we would do 10 minus 1, which is 9. 5 to the 9th power times 1/5 would give us 390,625. All right, and this may, if you type this in your calculator, it may give you that. Let's see what it does. All right, so if I use my calculator here and I do 1/5 times 5 raised to the 9th power, it gives me the answer here. So it will do order of operations for you. All right, that is all for task 3. If you have any questions, let me know. Lesson 13.3, task 4. Determine a term in a geometric sequence. The 7th term of a geometric sequence is 192, and the 12th term is 6,144. What is the rule for the sequence written in both function and subscript notation? All right, so we can see that we're given some information here. We're given a 7th term is 192 and a 12th term is 6,144. So the first thing they're going to do is solve for the first term, a of 1, in 2 ways. All right, so 192, we know that's our 7th term, so we plug in 7 for n. 7 minus 1 is 6. So we're going to divide both sides by r to the 6th power, and that leaves a sub 1 by itself. So really there was one step to that process there. All right, we're going to do the same thing with the other term given. So we're given our 12th term is 6,144. So they plug in 12 for n, which is r to the 11th power, and you divide both sides by r to the 11th. Now, when we have two things that are equal, so we know that a of 1, our first term, and a of 1, our first term, are equal to these two expressions, then we just have to set those two expressions equal to each other and we can solve. So we're going to have 192 over r to the 6th, and that came from right here. And then we have equals 6,144 divided by r to the 11th. All right, so what did they do here? Okay, they solved for r because that's the only variable. All right, how did they do that? So we can do cross multiplication. So we can start by saying 192 r to the 11th equals 6,144 r to the 6th power, because we cross multiply here. All right, and the first thing I'm going to do is get rid of one of my variables. So I'm going to divide by the r to the 6th. All right, so that's going to cancel on this side because 6 minus 6 is 0. Anything to the 0 power is 1, so the r's cancel here and leave just 6,144. All right, on this side, remember, we're going to do properties of exponents, same base. When we're subtracting from top to bottom, we subtract. Same base divide, you subtract, okay? So 11 minus 6 is r to the 5th power. All right, now we're going to divide both sides by 192. All right, so if you take your calculator here and we do 6,144, and we're going to divide that by 192, that gives us 32. So that tells me that r to the 5th power is 32. All right, now we want r, not r to the 5th. So what undoes a 5th power? Well, if you know what multiplies 5 times to give you 32, then you don't have to worry about that. But if you don't, you can take the 5th root. The 5th root undoes the 5th power. So what is the 5th root of 32? And you can do that on your calculator as well. If you do 5 and then go to math, come down here to where it says x root. So it has a cube root and there is a square root here, but we want to do a 5th root. So we're going to go down to where it says x root. So it's got a 5th root of 32. And it's going to tell us that the answer to that is 2. All right, now, does that make sense? Well, 2 times 2 times 2 times 2 times 2 is 32. So yes, that makes sense. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. Therefore, the 5th root of 32 is 2 as well. So that's just good number sense. It's always good to understand where those numbers come from. All right, so now we have a common ratio of 2, and now we need to find the first term. So you can use either one of these to now plug that in and solve for your a sub 1. So let's go ahead and do that. So let's do 192 over r to the 6th, and we know r is now 2. So 2 to the 6th power, and we know that's going to be our first term. All right, so again, let's use our calculator here. And I'm going to do 192 divided by 2 to the 6th power. And that gives us 3. So we know our first term is now 3. So a of 1 is 3. And our common ratio is 2. All right, so let's see what questions they have for us in task 4. All right, explain the process above for determining the common ratio. Okay, I think I just went through the steps and we just did that part. So it says, how can you use a of 1 times 2 to the 7 minus 1 power equals 192 to write the rule for the sequence? All right, so if I want to find a sub 1, I'm going to divide 192 by 2 to the 6th power, which is what we did right here, because 7 minus 1 is 6. So we're going to do this right here. So we're going to divide 2 to the 6th by 192. No, they've got it reversed. Divide 192 by 2 to the 6th to find the value of a sub 1. Then use the value of r and a of 1 in the general rule for the geometric sequence. So that is true. We are not going to multiply. You are dividing as I show here. All right, it says write the rule for the sequence in both function and subscript notation. The rule for the sequence in function notation, so function notation, a of n equals our first term is 3, and our common ratio is 2 raised to the n minus 1. And then subscript notation would be a sub 1. Our first term is 3. And it would look very much the same. All right, that's all for task 4. If you have any questions, please let me know.